Titration is a common laboratory method of quantitative chemical analysis to determine the concentration of an identified chemical reagent. The reagent will be either an acid or a base. In order for this to occur, an indicator is used. The indicator changes colors as it changes pH. For example, phenolphthalein is clear in an acidic solution but turns bright pink in a basic solution. Titration is a fundamental acid-base problem, and it can be very long and drawn out. The purpose of this video is to show you a much easier shortcut method in order to calculate titration problems. Now, I do have the full-length titration step-by-step solution on a different video. This is an alternative to see if you would prefer to use this form. So that titrations are reactions in which we measure the volume of a standardized solution, for example NaOH, that reacts stoichiometry with an acid. Now we would know the strength of either the acid or the base, and we know the amount of the acid and the base that we're using. And this, by knowing the strength of one of the chemicals and the amount of both used, we can calculate the strength of that missing chemical. For example, if we have 15 milliliters of 0.25 molar aqueous sulfuric acid, and it is required to neutralize 10 milliliters of an aqueous solution of potassium hydroxide, what is the molarity of this solution? Now I'm going to begin with reminding you that molarity, capital M, equals moles divided by liters, and normality equals equivalence divided by liters. So that if I convert my molarity here to normality, then I could do my NaVA equals NbVB, and I could solve my problem. Now to do this, I'm going to take my 0.025 molar H2SO4, and remember that that molar is moles over liters. So I know that 1 mole of sulfuric acid has 2 equivalents. Now I know it has 2 equivalents because if I look at H2SO4, it has 2 hydrogens. So if I multiply my 2 times 0.025, I get 0.05 for my normality. So I have my 0.05 normality of my H2SO4, and my problem said I had 15 milliliters. I have my KOH, and it said I had 10 milliliters, and I need to determine the strength of the KOH. Now it's wanting molarity, but I'm going to first do this as normality. So I'm going to use NaVA equals NbVB. And I can do this without converting my milliliters to liters. I can just solve for x. I can put 0.05 normality times my 15 milliliters equals my x times my 10. I'm going to solve for x, and that's going to give me the normality of my KOH. That gives me a 0.075 normality. Now, the question was, what is the molarity? So I'm now going to go back and I'm going to convert my KOH normality back to molarity. To do that, I'll have 0.075, and this is equivalence over liters. I'm going to multiply that times. Now looking at this problem right there, KOH has 1 OH. So we have 1 mole has 1 equivalent. The equivalent, again, is the number of OHs. Multiply that out, and so 0.075 molarity is my answer for the problem. It is much shorter and much easier to do the problems in this form. Let's do another example. It takes 12.5 milliliters of 0.3 molar HCl to neutralize 285 milliliters of NaOH. What is the concentration of the NaOH? Well, I can do an NaVa equals NbVb because I have an acid and a base. So I'm going to start off by my 0.3 molarity, which is moles over liter, of HCl, and 1 mole of HCl has one equivalent because it has one hydrogen. So I have 0.3 normality of HCl. I can do my NaVa equals NbVb. So I'll have my 0.3 normality of HCl times my 12.5 milliliters equals 285 milliliters times X. My X, which is my NaOH, and again this is going to be in normality, will equal 0.013. So I need to take this 0.013, which is going to be equivalents over liters, and convert that over to molarity. So looking at NaOH, it has one equivalent because it has one OH per 1 mole of sodium hydroxide. So my strength of sodium hydroxide is 0.013 molarity. Doing another problem, I've got an acid and a base. I have 0.75 molarity of NaOH, so that's going to be my moles over liters. NaOH, 1 mole has one equivalent, so that I have 0.75 for my normality for my NaOH. I'm going to take my NaVa equals NbVb, and I'm going to put my 0.75 normality for my base. Let's erase this over here, and we'll put it over here on the base side. So 0.75 normality, and we have 38 milliliters, and that's going to equal X times 155. My X will equal 0.18 normality for my H2SO4. Now I need to convert from normality to molarity. So I'll take my 0.18, that's equivalents over liters. That's what normality is. Now, H2SO4 has 2 hydrogens, so it has 2 equivalents for that 1 mole, for that 1 H2SO4. And so we're going to take that 0.18, we're going to divide it by 2, and so our molarity would be 0.09 molar for the H2SO4. One last problem here. Alright, on this one we have 0.45 molarity of NaOH. That's going to be moles of over liters, and that's NaOH. So we know that 1 mole has 1 equivalent, and that means we're going to have 0.45 normality of NaOH. We're going to do our NaVa equals NbVb. We have 0.45 normality here. We have 83 milliliters. We have 235 milliliters of our acid. We do not know its strength. We're going to solve for x doing basic algebra. 0.45 times 83 equals divided by 235. I get 0.158, and that's normality for HCl. Now I need to convert that over. 0.158 equivalents over liters for HCl. We have one equivalent because we have one H per each HCl. So we have a 0.15 or a 0.16 molarity for the HCl. These are much easier ways to do these problems. You're just converting back and forth between molarity and normality. It will save you 4 or 5 steps versus doing the longer form.